Let -3 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. The first thing we need to do is locate our reference angle, theta prime. Our reference angle is located between the terminal side of theta and the x-axis, located here. Now we can go ahead and form a right triangle, and then label the sides of the triangle that we know. Because the coordinate is -3, 4, we know that the base of the triangle is -3, and the height of the triangle is a +4. Next, we need to find the hypotenuse of the triangle. The hypotenuse can be found by using the Pythagorean theorem. R squared plus the base of the triangle squared, which is -3, times the square of the height of the triangle, 4 squared. So we get -3 squared, which is 9, 4 squared, which is 16. The sum of 9 and 16 is 25, and to solve for r, we take the square root of both sides. So the hypotenuse of the triangle is 5. Let's go ahead and label that on our triangle. And now that we know all three sides of the triangle, we can solve for our trigonometric functions. We know that the sine of theta equals the opposite, which is 4 in this case, over the hypotenuse, 5. And the cosine of theta is equal to the adjacent side, -3, over the hypotenuse, 5. And finally, the tangent of theta is equal to the opposite side, +4, over the adjacent side, -3. Go ahead and pause your video now and try this problem on your own. In this problem, we're asked to find all 6 of the trigonometric functions of angle theta. Let's first start by identifying our reference angle, theta prime, which is located between the terminal side of angle theta and the x-axis. We can label that on our diagram here. We can also draw or form our right triangle, and then label the sides of the triangle that we know. -1 and -√3, based on our coordinate. Next, we need to find the hypotenuse, and we can use the Pythagorean theorem to do that. We know that r squared equals x squared plus y squared. R squared equals, and x is -√3 in this case, plus y squared. So r squared equals -√3 squared is a +3, because a negative times a negative is a positive. √3 times the square root of 3 is 3. Plus -1 squared, which is a +1. So r squared equals 4. To solve for r, we take the square root of both sides, and we get r equals 2. Now we can go ahead and label the hypotenuse of the triangle as 2. Now we can find all 6 of the trigonometric functions of theta. The sine of theta equals the opposite side, -1, over the hypotenuse, 2. The cosecant of theta equals the hypotenuse, 2, over the opposite side, -1, which simplifies to -2. The cosine of theta equals the adjacent side, -√3, over the hypotenuse, 2. The secant of theta equals the hypotenuse, 2, over the adjacent side, -√3. We need to rationalize the denominator, multiplying the numerator and denominator by square root of 3. And we get -2 times the square root of 3 over 3. The tangent of theta equals the opposite side, -1, over the adjacent side, -square root of 3. The negative signs cancel out, and we're left with 1 over the square root of 3. Rationalize the denominator by multiplying the numerator and denominator by square root of 3, and we get the square root of 3 over 3. And finally, the cotangent of theta equals the adjacent side, -square root of 3, over the opposite side, -1. The negative signs cancel out, and we're just left with square root of 3.